Hi and hello. My name is Alex Benitez and I'm your TA, and I will be taking you through the organic chemistry video lab for the remainder of the semester. In order to facilitate this, I will be doing the lab for you guys and you will be writing a report based upon my performance. So I have been asked to include some questions along the way to ensure that you are actually watching the video and not just copying down the end. So I hope I can fulfill that. That will be 2 points against your grade if you don't answer these questions. And I will make sure that I make it clear when I am asking a question that needs to be answered. So today we are doing liquid-liquid extraction. And we are going to be separating the components of a binary mixture containing a carboxylic acid and a neutral substance. So both of these are insoluble in water, but by using the acid-base properties, we are able to separate them from each other and isolate them independently as a part of a purification process. So what we should know is that because benzoic acid is insoluble in water, we need to do something to it to make it soluble in water. And that will be the addition of sodium hydroxide as a base. This will give us the water-soluble version of a carboxylate. So the first question I'm going to ask is, what is the pKa of benzoic acid? And that should be pretty easy for you to find online. Hey guys, so in this lab, it's really easy to get confused with which vial contains what. So the first thing I'm going to do is label my Erlenmeyer flasks as 0, 1, and 2 with a small piece of label tape and a Sharpie.
0, 1, and 2.
Hey everyone, so the first thing I'm going to be doing is measuring out my reagent, which is going to be a mixture of benzoic acid and naphthalene. As we note in step 1, they want us to measure out 300 milligrams. And it will be a mixture of benzoic acid and naphthalene. So making sure I'm wearing my personal protective equipment, and let's get measuring. 234, 249, 266. Okay, so I measured out 0.308 grams. I'm gonna write that down on the board so I don't forget. So now I'm going to take heed of the note and say that I can exclude Erlenmeyer flask number 0 and instead transfer it directly into the centrifuge tube. Okay, so that is all transferred in. Next, I'm going to measure out about 5 milliliters, which is 1 full test tube. As you can see, the graduations, they say 4.5 for the very top one. So at the very, very top of it is going to be 5 milliliters. So I'm gonna measure out my 5 milliliters of diethyl ether and use that to dissolve. Ooh, shaky hands. Okay, so that's approximately 5 milliliters. So I'm just gonna pour this in. Okay, and I'm gonna put the cap on it. So you can see there's a solid at the bottom. So I'm gonna just keep shaking that until it's completely dissolved, because I don't want no chunky bits. Otherwise it will not work. So because benzoic acid is in its protonated form, it is soluble in an organic solvent like diethyl ether. So this next step will allow us to move it into an aqueous layer. Okay, now you can see that it's been completely dissolved. So I can move on to the next step. Using another test tube and our base, which is 3 molar sodium hydroxide, I'm going to measure out an additional 5 milliliters. Okay, so there's 5 milliliters right here. Pop it in and pour it in. Okay. Right off the bat, you can see that it has separated into 2 distinct layers, with the denser one being on the bottom and the less dense being on top. This comes to my second question. Which layer is which? Again, my second question, which layer is which? So now I'm going to shake, 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 and vent it. You might have heard some gas escaping. Shake 1, 2, 3. Vent it again. 1, 2, 3. Vent it again. It's starting to smell a little bit like naphthalene in here. 1, 2, 3. And vent it again. So I shook it again. So now if we look at it, we could see that there is a cloudy emulsion layer in the middle. I need to be patient and wait for there to be 2 distinct layers, and that could take a couple of minutes for it to separate. So for now, I'm going to set it down and let it do its thing. And we'll move on to the next step, which is step number 6. Again, you should be able to tell at this point which layer is which, and that should be included into your report. So now if we take a closer look at this, we can see that there is 2 distinct layers, with the separation being right here. Normally, I would do this with a flashlight if it is hard to tell, and I would be more easily able to see the separation. But for right now, this should be good enough for our needs. So step 5 says to let it separate, and they did. Step 6 says with a pipette bulb, I'm going to remove the bottom layer and place it into Erlenmeyer flask number 1, and then put it on an ice bath for 5 minutes. So I'm going to do that right now. Let me Okay, so I have prepared an ice bath for preparation of step 6. So I'm going to... Hey guys, so I just let the 2 layers separate as required in step 5. So here you can see that now there is a clearly distinct line. So the next thing I need to do is to pipette out the bottom layer and place it into Erlenmeyer flask number 1. So again, we should be seeing the meniscus, or the layer separation, to decrease in height. This is kind of difficult to do for the camera and for myself, but I'm just going to do my best. I have to bring it to eye level so I can see that last little bit. So I guess that means I'm coming down to you. Just a bit more. Okay, so it's right there. You see it coming down to the bottom, and we're done. It is okay to have a little bit of the second layer to come through, but we do want to minimize that. So now I've transferred all of that, and I'm left with 5 milliliters of the other layer. I'm going to leave that in here. So now I'm going to take Erlenmeyer flask and I'm going to place it onto my prepared ice bath for 5 minutes. See you in 5. Hey guys, so while I'm waiting my 5 minutes, I'm going to move on to step 7. So step 7 is to add sodium sulfate into Erlenmeyer 2 that also contains the top layer. It says to put 3 spatula tips full in there. And if you notice, there is a frostiness to this glass now. That means some of the powder stayed behind. This will be a source of loss when we do our yield or our recovery at the end. So we're adding sodium sulfate because it is a desiccant. This brings me to my third question. What is a desiccant? Again, what is a desiccant? Swirl it around, and we're gonna wait 10 minutes. Swirl it around, and I'm gonna wait 10 minutes for this one, and I'm gonna swirl it around every 2 minutes. Hey guys, just real quick, it's been about 2 minutes, so I'm gonna give this a little swirl, and while that's happening, I'm gonna start setting up for the next couple of steps. So I'm putting away the diethyl ether and the sodium hydroxide and throwing away any trash that I've accumulated up till here. Hey guys, it's been another 2 minutes, so I'm giving it a swirl, and I'm starting to prepare for the next step. So I have my 3 molar hydrochloric acid as well as my pH paper to help me tell when it is acidic. Oh, and by the way, I got an interview about the thing I told you about before. All right. Okay, so it's been another 2 minutes, but just an observation to make. The solution, I'm sorry I didn't show you this before, but it was cloudy and now it is clear. So we've been able to remove any of the aqueous layer using the desiccant. I'm gonna let that sit. While that's happening, I'm gonna take, let's adjust this camera. I have the 3 molar hydrochloric acid. And I'm going to take about a milliliter of it and add it to my flask number 1. So these are graduated pipettes. So the top right here, that is 1 ml. And I'm gonna take my glass stirring rod, stir it around a bit, being careful not to tilt it over and knock all over everything. And I'm going to test it on pH paper. So right now you could tell that it is blue and it has a pH of 13. So that's very, very basic. So I'm going to tear this into little squares. And I'm going to add another ml of this solution, the 3 molar sodium hydroxide. Some gas evolved. I'm going to stir it up again. I'm getting kind of worried it's going to fall over, so I'm taking it out. I'm going to test the pH. And again, the pH is still blue, so I'm going to add another ml. Again, some gas evolved. And stir it around. So the bottom layer should have been my sodium hydroxide layer. And I put 5 ml of 3 molar sodium hydroxide. So it should take about 5 ml for me to neutralize it, an additional 1 ml to acidify it. So right now I'm at 3 ml and it is still basic. I'm going to stir it while it's on ice. Acid-base reactions tend to be exothermic. Now I am at an acidic pH, which doesn't make sense to me. It should have taken another couple mils, but maybe the benzoic acid is helping along with it. So I'm going to put in 1 more ml. I prefer this to be at a pH of 1. If we take a look, you can now see that there is a precipitate in here. So I'm going to take 1 more ml. Put it on ice and stir it. And now you can see that it has become completely cloudy. And then if I touch this, there we go, that's the pH that I want. I have a red pH, so it's a pH of 0 to 1, and that's where I want to be for the maximum amount of yield. Okay, so after I do that, I'm going to drain this. So there's less chance of it getting knocked over. And I'm going to let my Erlenmeyer flask chill in here for another 5 minutes. All right, I'll see you in a bit. Guys, so I made a little mistake at this part. I said it was 3 molar sodium hydroxide, but it was actually 2.5 molar sodium hydroxide. So it shouldn't take 5 milliliters of hydrochloric acid to neutralize and acidify. It should have taken less than that. Sorry for the mistake. Hey guys, so I'm getting ready to do the next step, which is to decant this into a small beaker. Decant means to leave the solid behind, so I'm going to very carefully pour. It looks like I left all that solid back in here, and I have the solution in here. I'm going to take a glass stirring rod, and I'm going to place this onto a hot plate set at 50 degrees until it is completely evaporated. So just to show you guys, here it is, set to 50 degrees. And we're just gonna let it do its thing. Hey guys, so I'm going to speak up a little bit louder since we're working in the hood now. I've assembled my vacuum apparatus to help me collect filter number 1. Here's my filter paper. I'm going to turn it into a cone by just making a little triangle. And now I have a cone shape. Place this in here. I'm going to make sure that I mount my apparatus. Because I don't want it to fall over while I'm working.
Make sure you include the rubber adapter.
And turn on the water. So here is Erlenmeyer flask number 1. Water is on. I'm going to test the vacuum. I have some weak suction. So now I'm going to pour all of this into here. Ooh. And this is going to take about 3 times of pouring it out. I'm gonna get my ice water. And as we can tell right now, there's still a lot of solid left in here. So I'm gonna try and use the additional ice water to try and transfer the rest to maximize my yield. So that was 1 mil. I'm trying to coat the walls. Two mils. Now you can see that there is less of that precipitate. I'm not going to be able to get all of it out, but I can try and maximize it. Okay, and that's 3 mils. Okay, now it's time for the next question. What is the common application of naphthalene in the real world? Again, what is the common application of naphthalene in the real world? Outside of the lab. I wanted to show you guys the solid. Let me see if I can. So here I'm just wanted to show you the view of what it looks like. So I have the solid on top and it's still, I'm getting some drops out of it. I want it to be completely dry, or as dry as possible. So we're gonna let the water keep running. And over here, I have my benzoic acid. Excuse me, that is not benzoic acid. This is naphthalene in the diethyl ether slowly evaporating. I'm going to turn the heat to 60 just to help move it along. Hey guys, so I let this dry for another 5 minutes and you can tell that it's getting dry because you're starting to be able to see some cracks. I'm going to move on to the press drying portion of this. This is still evaporating. We just have a little bit more to go, but it'll be done soon. Hey guys, so I am finished drying my solid number 1, and I'm going to go ahead and complete the drying process by press drying it. So here is my solid. I'm going to take it out and very carefully press it in half. So now it looks like a little taco. Tacos. I'm going to transfer it to some paper towels and I'm going to do some CPR on it, press dry it. You see this big wet spot I have right here. So I'm gonna go ahead and transfer it to a different part of the paper towel and repeat the process. much less wet space this time. And just to be thorough, I'm going to transfer it to another part of the paper towel and do it again until I see no more wet spots. Okay, next question. Why is it important for me to dry it before I take a melting point and a weight? Again, why is it important for me to dry it before I take a melting point and a weight? Okay, looks like we got some more pressing to do. Okay, so I've done drying it. I have no more wet spots. I did lose a little bit of product during the drying spot. As you can see, I have some white stuff right here, unfortunately, but hopefully that won't be too much of an impact. So now it is time to weigh. Okay, so I am weighing it out. I've teared out my weigh paper. Now very carefully, I'm going to scraping off all of it from the weigh paper. And its weight is, this glass. Let it settle. .190 grams. Again, it's 0.190 grams for solid number 1. And I wanted to show it to you guys. If I can figure out where the damn lens is. Okay, here it is. So, without me spilling it all out, we have a nice white solid for number 1. Solid number 2 is finished drying. We're going to weigh that out. Scraping it off from the edges. You can see we have a nice collection of solid. So hopefully this should add up to almost 300 milligrams. Let's find out. we've measured out 0.117 grams for solid number 2. 117. Okay guys, so we have successfully separated solid 1 from solid 2. We were able to obtain almost the exact amount that I measured out from the beginning. And now all that is left to do is to measure some melting points. So hang tight, we're almost done. Hey guys, so I have prepared the melting point apparatus, and here is solid number 1. And here is solid number 2. And I'm going to have them go at the same time. Let's see. Maybe I can let you in on the action. $80, $82. Solid 2 melted from 80 to 82. $119, it's beginning to melt. $123, it stopped melting. Hey guys, so just to review everything that we've done today, we had a binary mixture of benzoic acid and naphthalene. When we introduced the benzoic acid to sodium hydroxide, we created a water-soluble version that has a carboxylate. Then we removed the organic layer of the diethyl ether that contained the naphthalene and transferred it to another container. Then, in the container containing the benzoic acid, we acidified it to make it water insoluble, and we collected it over a filter frit. Remember, we started with 308 milligrams of the mixture, and I was able to obtain 190 milligrams of the first solid, which had a melting point of 119 to 123, and another solid 2 for 117 milligrams, and it had a melting point of 80 to 82 degrees Celsius. My last question to ask you is, how are you doing with all of this? I know it's not related to the class, but if you need a place to vent about your coronavirus concerns, I'm happy to lend an ear. Thank you for your time. Have a wonderful day.